Okay, hello and welcome to lecture 2. In the previous slides, we saw switches, hubs, interconnections, and media structures, topologies, etc. And now we will see how communication occurs between the hosts on that network. There is an old model and there is a new standard model which we are using right now. In the older model, if you were using different operation systems related with the different vendors, those different products won't get in a communication between each other because all vendors had their own communication protocols back in those days. They were using their own addressing methods. For example, Apple computers can't get in a communication with the Windows, etc. So they bring the market to a new standard model for a data communication. This model's name called Open System Interconnection, Osi model, which is including layers. This layer structure includes 7 different layers. We will see each of them. And as you see, it reduces complexity and there are different protocols working on. We can make troubleshooting easier. It provides us to make troubleshooting easier. Let's see from bottom to top. First we see physical layer. On this layer we are dealing with the electrical signals, cables, ones and zeros. We call it physical layer. Hubs are also work on this layer. The upper layer is data link. On this layer we make physical addressing. There are 2 addressing types occur on the hosts. One is physical and the other one is logical. Physical address locates on our interface card defined by the vendor and cannot change. And logical address can be the IP address. So we can say the data link is a layer that the physical addressing is done. In other words, it's the layer that MAC addressing adds on this data. And at the same time, devices which works with MAC addressing work on this layer. For example, switches. Switches are also can work with layer 3. We call it backbone switches. We will see them later. Okay. On the network layer is actually we will deal with the most of the time. It's the layer that IP addresses are located. Logical addressing is doing here. Routing processes and protocols are doing at this layer. For example, ICMP ping packets are protocols. Routers and multi-layer switches, also called layer 3 switches, working on this layer, as I said. And the transport layer. The transport layer is the layer determined how the data will transmit. There are TCP and UDP protocols. You may have heard them before. As you know, there are TCP and UDP logical ports located on the devices. For example, when you connect a website, you connect TCP/80. You can communicate with HTTP protocol. If you connect TCP/21, you communicate with FTP protocol. So transport layer protocols connect us to application layer, application protocols we will communicate with. Session layer. Session layer is when you're going to connect with the application layer, it creates a session depending on your transport layer, whether if you are using TCP or UDP. And the presentation layer. Presentation layer is the layer we determine the format and structure of the data. It provides encryption. It formats data, as I said, negotiates data transfer syntax for the application layer. And the application layer. Application layer is a layer we communicate and use directly. For example, HTTP, DNS, FTP, Telnet, and all protocols we use directly working on this application layer. Depending on which protocol you say on the application layer, you also say which protocol you will use on transport layer. For example, when you use HTTP on the application layer, you say you will use TCP on the transport layer. That's because HTTP works with TCP protocol. For example, when you use DNS, you use UDP53. There are multiple protocols. I don't remember the number of them. We will see them later. Okay. And here you can see it's a 7-layer model. In this 7-layer model, when the data goes out from the sender, information adds in every layer and data is encapsulated. This process called data encapsulation. So, after the data is encapsulated, the receiver cuts the header step by step to get data, and this process called data de-encapsulation. This is the opposite of the encapsulation. Okay. Peer-to-peer communication. Peer-to-peer communication, the data separate to the segments on the transport layer. So the data on the transport layer called segments, on the layer 3 network called packets, and on the layer 2 network called frames. Data comes from here and it's separated to segments, port numbers added to it, then data packet here, and the IP address added to it, and then the data added to IP address sends layer 2 and the MAC address added to it. Then it goes ones and zeros. And there's a standard called TCP/IP we are using right now. And after Osi reference model, actually there is no difference between them. On the other model we have 3 different application: presentation and session layer, and here we are dealing with a single application layer. Transport is the same, and a network becomes the internet layer here. And the data link and physical link called the network access layer. As I said, they're exactly the same, but here we are dealing with the 7 different layers, and here we are dealing with the 4 different layers. Summary: the Osi reference model defines the network functions that occur at each layer, and it's just getting things easier. We can make troubleshooting easier. We can see how the data sending and receiving process is doing. We separate them layers, so the network layer provides connectivity and path selection. Data link layer defines how data is formatted for transmission and how access to the physical media is controlled. Okay.